In this session, we are going to build two clustering methods, that is hierarchical and K-means. So first we will look at the data set. So we are going to deal with customer spend data set. This is the data set. So we are going to build a K-means clustering for this data set. And for shopping data set, we are going to build a hierarchical data set, a hierarchical clustering. So first we need to import basic libraries or the basic packages. So let's import numpy as np, import pandas as pd, matplotlib dot pyplot as plt, import cbone as SNS. But cbone, let's take cbone. Okay, so we are going to take shopping data set first. So this is our shopping data set. So let's call the variable name as customer data. Is equal to pd dot read underscore csv of. So we'll mention the path over here. So this is the path, file path. So let me run this code. Okay. So let me check the customer data. What happened? Code. Customer customer data.head. So these are the features that we have. So we are going to build a model for these features. So let's see the shape or the number of rows and columns for our data set. So customer data dot head. So dot shape gives the rows and columns. So we have 200 rows and 5 columns. So these are the 5 columns: customer ID, genre, age, annual income, and spending score. So if you see this data, so most of the time we are dealing with annual income and spending score. So for clustering method, so for just we'll consider annual income and spending score. Even the genre as well as age matters. So first let's do the describe function. So customer data describe. So customer.describe gives the 5-point summary, that is IQR, and as well as it will gives the mean and standard deviation. So now what we have to do is that, so we are only considering these two columns as features that are going to be useful for our clustering. I mean, these two features will help us to determine to which cluster our value our data points belongs to. So let me call data as a variable name. So data is equal to customer data of so dot ilog. So we want all the rows and we want only the second 0, 1, 2, 3, 4, 3 and 4. So 3 till everything. Okay. So let me print data. Okay, so we have got this annual income and spending score. Okay, so now run the endogram based hierarchical clustering. Okay, so for running a endogram based hierarchical clustering, we have to import scipy.cluster.hierarchy. So import scipy. In scipy, we have cluster, and in cluster, we have hierarchy model. So hierarchy. Let's give an alias for this, SCH as a SHC or SCHH. So import scipy.cluster.hierarchy as SHC. So now I'm going to draw a dendrogram. So PLT.figure of fixed size equal to fixed size equal to, so let me pass it as 10,7. So let's call the title PLT dot So title I will call it as customer dendrograms because we are so this is not customers, this is shopping data, right? Shopping data dendrogram. Okay, so we have to write dendrogram. So D and D variable name is D and D. So now we have our alias SHC dot. We want our dendrogram, so we will use dendrogram. So let me run this first. Okay, dendrogram of SHC.class linkage of we will pass data and we have to pass method as well. So method. So let's see what are the parameters that are there in the dendrogram. So dendrogram has ZP and we have passed SHT dot linkage, right? So inside linkage, what are other parameters that are present is method. Okay, so method over here is used is single. So let's see other methods that we know. So methods we know are other methods are like word method. So we will use word method, which is a sum of square error. So we'll pass method is equal to word. Yeah, this is our dendrogram. This is like a parent, and we have formed cluster of data points. So we have our cluster. So if you see, this is one cluster, this is second cluster, this is third cluster, and this is the fourth cluster. Okay. So now let's do the predict the clusters of observations. Okay. So for that, scalar here dot cluster agglomerative clustering. Okay, cluster is equal to agglomerative clustering of. So we'll pass inside this. We'll pass number of cluster as let me pass number of clusters as 5 for now, and then we will pass affinity. So affinity here is we are taking as Euclidean. By default, is it as an Euclidean distance it is going to consider. So number of clusters we have is 5 for that. That's what it is. Okay. So let me run this. So let's do the prediction. C cluster dot predict of. So I'm going to pass the data over here. So sorry, actually we have to do fit predict. So we have to fit and then predict. So I'm going to pass the data over here. So this will do the prediction. So there is some error. Now model.scale this is okay. This is the prediction. So when we took number of clusters as 5, so what we have done is that we have instantiated agglomerative clustering. And then what we have done is that after instantiating, we are training the model, and then we are doing the prediction of the data set that we have. So we got these kind of values. So now we will plot the clusters. So P dot figure of size equal to 10 comma 7 consider. And now we have to do the prediction, right? So PLT what we will do scatter plot. PLT dot scatter of. So I will take data of. I will take data of. So we have our data, right? So 3 and 4 is fourth column. So I will take data of zeroth column, all the rows, comma zeroth column, comma data of all the rows, comma first column, comma clustering. Cluster is equal to, that is C is equal to clustering dot label, cluster dot labels. Okay, we run this code. So figure, let me run this code. SVLT dot figure. Okay, so 0 is an invalid key. Okay, so there is some error. Let me check it once again. Okay, figure fixed size is equal to, this is fine. Data of everything dot zero, data of zero cluster. Yeah, let me pass color map as well. So there is some slice of is the invalid key, slice of none comma none. So there is some problem with this data set. Let me check dot data dot ILOC and data dot ILOC. Okay, so we have got a plot. So we have to access index location. Okay, so these are the 5 clusters that we have. So this, so we have plotted our hierarchical cluster, so which is a dendrogram. So 1, 2, 3, 4. So instead we have passed 5 cluster and we have got our prediction. So now we are going to build a KMeans clustering model. So for that, first import libraries we have already imported. Now we are going to consider the second set of data sets. This is the data set we are considering. So I'm going to copy the file path. So data set is equal to pd.read underscore csv. Now I'm going to take this data set and let me print this data set dot. So these are the columns that we have, and now let me build a 5-point summary for this. So 5-point summary for this is data set dot describe. So this give the 5-point summary as well as mean and standard deviation. So now we will do the feature scaling. So we have our data set. So now we'll do the feature scaling. So first you have to do the standardize the data to normal distribution. Okay. So what we'll do is that, so here we know that customer ID and name column are not useful. So we'll access from average monthly stipend till staple items. So zero, from to index. So data is equal to data set dot ILOC of, so I want all those, and I want only from second till end. Okay, and this dot values I will do. Now what you do that to do scaling. So from sklearn import processing. Okay, so let's call it name as dataset1 underscore standardized is equal to the processing dot. So I will call it as pre-processing dot. Let's do the scaling. Scale of, so what we have to scale data. So now data set underscore standardized is equal to pd dot data frame of, so what we are going to standard pd dot data frame of data set standardized. Okay, so we have done the feature scaling. So now we are going to plot WSS plot or elbow curve for optimal cluster identification. So we are going to find the optimal K value using this elbow curve. For that, we have to do dot figure of fixed size is equal to 10.7. So now from sklearn, so from sklearn dot cluster dot K means. Okay. So now let's see WCSS diameter. Let's see. So I'll take for I in range of. So let me pass 1 comma 11. Let's have value still 11. So K means is equal to K means of number of clusters is equal to I will pass, and after that I will part initialize is equal to. So let me see the other parameters as well. So in it is K means plus we are taking, and random state is, so we can take 42. Let me take random state is equal to something like 40. So here, if you see here, like we have initializing with K means plus. So if you go here, you will see it's a callable or a array-like shape. So K-means is a selects initial cluster centers for K-mean clustering, a smart way to spend up convergence. See section. This is nothing but it selects the initial cluster centers for K-mean clustering. That's it. Now what we have to do? We have to do the prediction. K-means dot predict. So before that, we have to fit on the training data set. So fit on the data set, that is standardized data set we have. Data set that standardized. Now we have to look for the best value of K, right? So we will find out the score. So that will be get by K means inertia. Okay? K means dot inertia. This will give you the score that like diameter, WCSS diameter, it will give. So based on the WCSS diameter, we are going to take the K means value, that is K value for clustering. So now we will do PLT dot plot of range of 1 comma 11 comma, we will plot it for WCSS. Okay, so let me will take PLT dot title as, so at the elbow method, and I'm going to take PLT dot x label as number of clusters, and PLT dot y label as WCSS. So I've got the plot. So if you see this plot, we have our point over here. At 3, we have an elbow. So we will take the elbow. At 6 also, we can take an elbow. So we'll pass values and check. So the score that we get. So we pass K means is equal to K means of number of clusters is equal to 6. I will pass, and random state is not required, but let me pass some random state. So we had taken random state 20, right, in the previous thing. So let me take 20 only. So now, so we have to do the predict training. We have to fit predict for the data set, standardized data set. Okay. Underscore K means is equal to K means dot fit. We will do fit and then predict on our data set. So standardized data set. Standardized. The data set standardized. Sorry, that name is data set standardized. And what we'll do is, so the value for this will lie from 0 to 5 because we have taken 6 clusters. Best thing would be to take 3 clusters as well, because I think since our data set is too small, I mean, this is too small, so better to go with the number of clusters as 3 instead. So, and I will start my clustering is yk means 1 is equal to yk means plus 1 I will consider. So now we will create a data frame. So cluster is pd dot data frame. So pd dot data frame of y underscore KMeans. Okay, so new data frame called clusters. We have cluster we have created. So what we'll do is that, so data set one, we'll call data set one. So we have a data set one, right? So let me check data set one is there or not. Okay, data set one, let me check if data set one is present. Okay, this is our data set one. So data have been given data, which is data set one. So there somewhere I had given data set one. Let me check. So is it our data set or data set one? Okay, so that is our data set, maybe. So hold on a second. So data set, okay. So this is our data set. Okay, so what we'll do is that, so data set of cluster, we'll give it as equated to cluster. Okay. So we will have our prediction, and for checking, so you can data set. Now we will get a new column for cluster. Okay, so we have a new column called cluster. Okay. Yk means 1 is yk means plus 1. So data frame yk means 1 we have to take. So it's fine now. Now what you have to do is that, so we create a data frame. So let's create a data frame. So k means cluster. K means cluster. So I'm going to call the variable name as created cluster and pd dot data frame of, what I'm going to do is that I will round off values till 1 decimal. So I'm going to take data set I'm going to consider, and I'm going to group by I'm going to do group based on data frame of the cluster. Data cluster. I have passed a data set dot group by a cluster, and I want the mean. Okay, so dot mean I'm going to consider, and comma till only first time. So till only for 1 decimal you want. So I'm going to print k mean cluster. So there is some problem with this. So must be a callable connection one was passed. Let me check what is the problem. So this should be coming over here. Okay. So we have got the round of the, like we have done the group by based on cluster, and we have got numerical values. So now what we can do is that scatter. So there is a Shilote score we have already seen in the previous section class, right? So this is a Shilote coefficient. So we will actually calculate the score of that. For that, from sklearn dot metrics import Shilote. Shilote. Okay, Shilote score. 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 Okay So score is equal to score equals to we have Silote score of data set and standardize, comma, y underscore k means. So this is our prediction y underscore k means like the number of clusters we have here, and it is a standardized data set. So this will give the score accuracy kind of thing like accuracy score. This Silote score in our case. So we have got the Silote score as 32.4%. So this is what everything we wanted to know about clustering, and I have covered all the topics in clustering. I hope you enjoyed the session. So in the next session, I'm going to cover the remaining part of machine learning algorithms. Okay. Thank you for attending the session.